you ever felt like the puzzle you've been assembling your whole life suddenly stopped fitting together? Like the pieces that have sat in their places for centuries suddenly changed shape. 2025 was supposed to be the year of answers. We launched Euclid to full capacity. We pointed James Webb into the deepest darkness. We were waiting for confirmation. We expected physics textbooks to just get a couple of new chapters. But instead of answers, the universe threw something at us that made even the most skeptical astrophysicists exchange nervous glances in university corridors. This year, we didn't just find strange rocks. We discovered an object that entered our solar system and behaves as if it has a plan. We saw galaxies that, by the laws of physics, should be dead, yet they shine brighter than the entire Milky Way. And finally, in April 2025, we received a signal from an exoplanet that forced us to face the scariest question of all. Are we ready to hear the answer yes? Today, we aren't talking about science fiction. We are talking about raw data that is scarier than any horror movie. This is the chronicle of the anomalies of 2025. Objects that shouldn't exist, but they are here. Let's go. Let's go back to July, a scorching July in 2025. The Atlas Early Warning System in Chile spots a dim point. At first, everyone thought, just another comet. It was named C/2025N1. Standard procedure. But a week later, when the orbit was calculated, silence fell over NASA. The orbital eccentricity was off the charts. The speed, 61 kilometers per second relative to the Sun. This isn't a rock from the Kuiper Belt. This object is not from here. It received the official designation 3I Atlas, the third interstellar object in human history after Oumuamua and Comet Borisov. But if Oumuamua was a strange cigar-shaped rock, 3I Atlas turned out to be something else entirely. The first oddity, the heartbeat. When telescopes in Hawaii started tracking the object's light curve, they noticed it wasn't just rotating. The object was pulsing. Its brightness changed with a mathematical precision that is hard to explain by a simple rock tumbling through the void. But the real shock came in August when spectroscopic data from the Keck telescope was published. Ordinary comets are dirty snow, water, carbon dioxide, dust. But do you know what 3I Atlas is made of? In its tail, they found traces of nickel and chromium. And not just traces, but a compound resembling nickel tetracarbonyl. For those far from chemistry, in nature, in the cold vacuum of space, this compound is almost never found in pure form. On Earth, it is an industrial catalyst. It is a product of processing. Harvard professor Avi Loeb, whom many criticize for being too bold, released a paper in November. He asked a simple question. What is the probability that a chunk of rock from another star system would consist of industrial alloys and fly straight toward Jupiter's orbit? The trajectory of 3I/Atlas passes suspiciously close to Jupiter's Hill sphere, the zone where the gas giant's gravity dominates. If you wanted to slow down an interstellar probe, you would use Jupiter for a gravitational assist. Of course, NASA's official stance is insufficient data to confirm artificial origin. They talk about a rare type of metallic asteroid ejected from the destroyed core of a dead planet. But think about it, a metallic asteroid that accidentally flies into our neighborhood, pulses like a beacon, and passes by the largest planet in the system. Coincidences happen. But in 2025, there have been too many of them. While we were staring at the visitor inside our system, another telescope was looking at the structure of reality itself. On March 19, 2025, the European Space Agency released the first giant map of the universe from the Euclid telescope. Euclid's mission was simple: map billions of galaxies to understand how dark matter works. Scientists wanted to confirm the standard cosmological model. They wanted to check a box and say, Einstein was right, everything is fine. But the map we saw in March, it's terrifying. Imagine you bought a map of a city. You know that neighborhoods should be populated somewhat evenly. But when you open the map, you see that all the houses are huddled together in huge, dense piles, and between them are giant wastelands where there is nothing. The 2025 data showed that the universe is clumping much more than our theories predict. The cosmic web is too high contrast. This sounds like a technical detail, but the consequences are catastrophic. It means one of two things. Either our understanding of gravity is wrong, or dark matter isn't what we thought it was. It's not just cold and dark. It interacts with itself. Or even worse, it changes over time. In 2025, the term Hubble tension stopped being a debate among theorists. It turned into a crisis. We measure the expansion rate of the universe by nearby stars. We get one number. We measure it by the cosmic microwave background, the early universe. We get another. And these numbers have stopped matching entirely. Euclid's map was supposed to build a bridge between these numbers. Instead, it blew the bridge up. Astrophysicist Dr. Carol Mundell said something in an interview this spring that stuck with me. We are looking at the skeleton of the universe, and it feels like it has extra bones. Why, he discovered structures billions of light years across that simply couldn't have had time to form in 13.8 billion years. Gravity needs time to pull matter into a pile. But these great walls and rings are already there. It's as if someone hit fast forward at the beginning of time. And that brings us to the next find, which finally shatters our understanding of history. If Euclid showed us that the modern house is built crookedly, James Webb looked into the moment the foundation was laid and found a skyscraper. Throughout 2024, we had hints. But in 2025, confirmations poured in like a landslide. Galaxy J, ADESG, SZ140 and its sisters. We see them as they were just 290 to 300 million years after the Big Bang. According to old textbooks at this time, the universe should have been a nursery. Chaotic gas, the first timid stars, darkness, But Webb showed us monsters. These galaxies are too bright, too massive, and they have too many metals. To get that much carbon and oxygen, you need generations of stars that were born, lived their lives, and exploded. That takes hundreds of millions of years. But we see these elements immediately. Imagine walking into a kindergarten and seeing a bearded professor giving a lecture on quantum mechanics. You ask, "How old are you?" And he replies, "I'm 3 days old." That is exactly how cosmologists feel right now. In 2025, a series of papers came out trying to save the theory. One idea is little red dots. Scientists suggested maybe these aren't galaxies full of stars. Maybe they are giant black holes greedily devouring gas, and we are mistaking their light for starlight. It sounds logical, but it creates an even scarier problem. Where did supermassive black holes weighing millions of suns come from instantly after the birth of the universe? A black hole needs to grow. It needs time to eat mass. If they were already there, giant and hungry, it means they didn't grow. They were born that way. Primordial black holes. Direct collapses of matter. If this is true, then our universe in its youth was a much wilder, a more terrifying place than we could have imagined. A place where the laws of thermodynamics were pushed to their absolute limit. But let's step away from dead rocks and ancient holes. Let's talk about what matters most to every single one of us. Life. All through 2024, debates raged around the planet K2-18b. This is a Hyson world, an ocean world with a hydrogen atmosphere 120 light-years away. Back then, the Webb telescope noticed a molecule in its atmosphere, dimethyl sulfide DMS. On Earth, this gas is created only by life. By plankton. No geology, no volcanoes produce it in such quantities. Skeptics shouted, "Data error, instrument noise." In April 2025, Webb pointed its MIRI instrument at K2-18b again. 8 hours of continuous observation. The results, published this summer, didn't put a period at the end of the sentence. They put an ellipsis that makes your blood run cold. The signal is there. It's weak. At the 3 sigma level 99.7% probability it's not noise, but it is there. We saw methane again. We saw carbon dioxide again. And we see that ghostly trace of dimethyl sulfide again. Scientists are now in a deadlock they call the Biosignature nightmare. We see smoke, but we don't see fire. If there is life there, it's not just microbes. To saturate the atmosphere with that much gas, the ocean of K2-18b must be teeming with life. It must be a planetary biosphere. But why are we afraid to say yes? Because in 2025, we also learned that comets can produce similar organic molecules under certain conditions. We are standing on the edge of the greatest discovery in history, but we are afraid to take the step. Imagine the irony. We found a planet that smells like the Earth's sea. But we are too far away to scoop up a bucket of water. We can only look at graphs and guess, is it algae or unknown chemistry from an exotic world? 2025 is coming to an end. And if you ask scientists what we understood this year, the honest answer would be, we understood how little we know. We found a probe or a rock made of industrial metals. We drew a map of the universe that contradicts our laws of gravity. We saw the light of galaxies that shouldn't have had time to be born, and we caught the scent of life that we are afraid to believe in. Maybe the universe isn't broken. Maybe it's our glasses, the lens through which we look at it, that are broken. Old physics is bursting at the seams, and that is beautiful, because it is in the cracks of old theories that new discoveries are born. We are no longer alone in an empty, dark room. The room turned out to be crowded, noisy, and far more complex than we thought. Thank you for being with us on this journey. Subscribe if you want to be the first to know what happens when 3I Atlas approaches Jupiter in 2026. I have a feeling the most interesting part is just beginning. See you soon.